For this section, we're actually going to be starting to look at working with logarithms and how we can kind of put them together and tear them apart. We're going to do something called condensing and expanding them. And they have some kind of weird properties that go along with them. But we're going to go through each one of them in this lesson. So how do you expand and or condense logarithmic equations? This will eventually lead into using logs to actually solve equations, which we haven't really done yet. Just a little bit before. We were changing from exponential to logarithmic form back and forth, but this will also allow us to solve harder equations. Okay, so I'm also going to use the calculator from before us, which I posted on Teams. It's this TI Inspire apps. This is TI-84 online calculator, so it's very similar to the one that's in class. So I'm going to use this to do some of the logs on here. So it says we're going to do the calculator to solve the following. So I'm going to do log base 10 of 100. Now, if you remember, log base 10 means you could also write this as just log of nothing with 100. So if you remember, the base 10 does not have to be written there. So I'm going to actually just type in log 10, log 100, and see what it is. Use this button here, log. I'll type in 100. And then send that over, and we get... See, it even says log base 10 of 100 is 2, even though I didn't type base 10. So the answer is 2. Now I'm going to go down to part B and see how it changes when we have log base 10 of 10 plus log base 10 of 10. So let's see what log base 10 of 10 is. So again, I don't have to write that out. I'm going to actually do it like this, right? I'm going to do log of 10 plus another log of 10. Let's see. So what's log of 10? Log 10. That answer is 1. So we actually get 1 plus 1. Because they're both log 10. So log 10 plus log 10 would be the answer of 2. Now, if you notice, I'm trying to hopefully make this connection where these two answers here are the same. So that must mean that these two things are the same. So think about that a little bit of how this with 100 here is the same thing as having them split into 2 with a 10 and a 10 and a plus sign. All right, let's try another one here. I'm going to do log base 7 of 343. Now I actually have to put the base there because it's not 10 anymore. So I'm going to do log with the base 7, 343. So it says log base 7 of 343 is 3. All right, the answer is 3. So what do you think I'm going to have down here if I do log base 7 of 49 plus log base 7 of 7? Well, we'll see. I'm going to do one each time. Let's do log base 7 of 49. Log base 7 of 49. That would be 2. So this answer is 2. Plus, do log base 7 of 7. And that is 1. 2 plus 1 is 3. So again, we get the same answer between these two. So how is that working out? Why is that happening? This one term, 343, is the same as having these two added together. Same thing here. 100 is the same thing as adding these two together. So what's actually going on? Why are they the same? So if you notice, if we put 10 and 10 together with multiplication, that gives you 100. Does that work the same way over here? What's 49 times 7? What if I multiply them together? Do I get 343? You actually do. So there's this property here when you have addition between two logarithms, and we have the same base here, we can multiply the numbers that are next to it. And that creates one logarithm by multiplying them together. So for instance, let's try an example. Now I'm going to go and do something called condensing. It says condense each expression into one logarithm and check to see if they're equivalent. So by using the strategy from before of how we can put this plus together into one log, I'm going to write log. They both have a a base of 3, so log base 3. And then I'm going to put 27 and 243 together. So I'm going to multiply them together. I'm going to take a calculator and do that. $243 times 27. So I get 6,561. Now let's see if that actually is the same answer as this one here if we add these two together. Let's do log base 3, 6,561. 6,561. That's an answer of 8. Now, why don't we just type this whole entire thing in here? We'll have log base 3 of 27 and log base 3 of 243. I think I can do all that. Log base 3 of 27 plus log base 3, what was it, 240? Yeah, 243. And that also gives us 8. So this is 8, and this side is 8. So this method does work. We're going to do another one. Log base 9 of 81 plus log base 9 of 9. That would be log base 9. Keep the same base. And we're going to multiply them together. So that would be 81 times 9, which is 729. Let's go ahead and check that. Log base 9 of 729. Oops. That's going to be 3. So this is 3. Now let's check the other one. Log base 9 of 81 and log base 9 of 9. So we'll do 9 of 81 plus log base 9 of 9. And that should also give us the answer 3. It says use rules of logarithms to condense, which is what we actually did and got 3. So both sides are 3. Okay, so as long as they have the same base, this is the first property. If you have, I'll do it this way. If you have addition between two logs, as long as they have the same base, you can take the numbers that are beside them and multiply them together and make one logarithm. So you can go back and forth. You can do condensing, which is going this way, make it into one logarithm. That's called condensing. And then if you go the other way, this way, this is called expanding. Expanding. It's not writing too well. So what we just did is we did condensing. We went from having the plus, having two logs, back to just one logarithm. And this property works. So let's practice some expanding. Now I'm going to go and see, okay, so there's multiplication between these two numbers here. I'm going to expand it into two different logs. So we're going to keep the same base, so it's log base 10. Now, remember, if it's base 10, we don't have to write 10. We'll just leave it as log. So we don't have to write the base here. So it'll be log of 8 plus log, same base 10, of x. Now it's expanded. All right, part B, we have log base 2 of 3n. Here we do have to write the base. So log base 2, there's multiplication between those two, so log base 2 of 3 plus log base 2 of n. It's that simple. You have to remember to write log plus the same base. And then this last one here, we would write this as log base 5 of 25 plus log base 5 of 125. So we're not solving this. It just says to expand it. You could actually solve these and get an answer, which I believe would be, I think it's actually 5. Yeah, 2 plus 3 is 5. But we're just practicing expanding them. So I want you to try to do some huddle. We're going to expand a couple, and then I have a bunch more. We're going to be condensing them. So if you look at the huddle here, make sure every single base is the same, and then you can do it. For part C, you will see there's an issue. 4 and 7 are not the same. You cannot condense. We cannot condense. I don't know if there's more like that. I haven't looked to see. But if there ever is two bases that are not the same, you can't put them together. So please do not try to put 4 and 7 together by multiplying them. I think the rest of them you should be able to do. There might be one more on here that you can't do. You should be able to find that. Okay, moving on to the next property. Well, if we did pluses between them and had to multiply them to get them back together, now we're going to do the other two operations. If we have subtraction between the two, that should be the same thing as division. So I'm going to go ahead and type this one out, log 100 minus log of 1,000. Let's do that. Log 100 minus log of 1,000. Maybe we'll even say condense it again. Yeah, use rules of logarithms to condense. We get -1. So this answer is -1. And then here on the right side, we should have the same answer. But now it's using division with subtraction. See how there's two lines here? So we're going to do log of 100 divided by 1,000. Let's see if that works on here. Log of 100 divided by 1,000. There we go. And that should also give us -1. Simplify the expression to -1. So this is the new property. This is the second property. If you have subtraction between the two logs and they have the same base, remember these all have the base 10 because you don't see them. It also says down here, must have the same base. Then you can just change subtraction to division. You make it into a fraction. So this is what we started with. Log base b of x minus log base b of y. Doesn't matter what these two numbers are, or letters, whatever. If that happens, the letter or number that is next to the minus sign, that goes on the bottom of the fraction. So just remember that. If this minus sign, whatever comes after the minus sign, this has to go on the bottom of the fraction. It's the denominator. So this is the numerator. This is the denom. And again, you have to have the same base, and you have to write that base as well. All right, so let's do some expanding. We're going to go the opposite direction. So if we have x divided by 8, we're going to write this as two different logs. So let's just write them both out. Log base 4. Log base 4. The top number is x, so it's log base 4 of x. The bottom number is 8, so we have 8. And between them, since this is on the bottom, we have a minus sign here. If you accidentally wrote them the other way around with 8 here and x over here, this first one would still have to be the -1, just so we're clear about that. That's what makes a division. B, log base x. That's okay. We can separate that. So we'd have log base x, top number is y, minus log base x, bottom number, z. And the last one, we have log base 2 of top number 6 minus log base 2, bottom letter here is y. So this one might be maybe more obvious as to why this would be advantageous to split them up. This you could actually get a number for, but if it was like this, you would not be able to figure out the number because there's a variable here. This would give you a number though. You could type that into the calculator and get an answer. This one you could not. There's a y there. All right, example 6, we're going to condense these. So if we see a minus sign, this is what goes on the bottom. Just remember, we have the same base, so we're good. Log base 2. And then this would be x divided by 17. X is on top, bottom, right? T, B, top, bottom. All right, here we have log base 5 and log base 2. Not the same. Can't do it. Cannot condense. Not possible. Exclamation point. And the last one here, we have log base 3, so we can do it. Log base 3, 15's on top and the bottom, since there's minus signs next, over 5. Oh, actually, we can go a little further with this one. This is the first time we can actually keep going. We can simplify 15 over 5. So this is the same thing as saying log base 3, 15 divided by 5 is 3. And again, you could put this into the calculator to get an answer, but I'm just trying to condense it. The answer of this would actually, I think, be 1. And you can double check. Oops, not 23, 3. It's 1. And the only reason I know that is because when you look at this, if you remember, if you do like the circle thing, right, it's supposed to be 3 to the first power equals 3. That's what you're doing. So that's how I figured that out. But you have to remember how to do the change in exponential form. Okay, we have another team huddle. You're going to do some more expanding and condensing. And there's one last thing we have to go over, then we're done. Might do a couple of those with you and be done. All right, converting logarithms not in base 10 to base 10. So I think at school with our new calculators that I have this year, I think we're going to have to do this unless I figure out a way to do the bases, because our calculators may not be able to do bases. So if you have log base b of x, and you're trying to put this in the calculator, but you don't know how to find that little tiny b, you can rewrite this in a different way and get the same answer. If the calculator only has the button log, or your phone only has the button log with not a base part to put in, like if this calculator only had this button log, how would you do that? There's a way to work around that. If you want to solve something like this, you take the top letter x, you do log base 10 of x divided by log base 10 of b. So this will work in any calculator. If you have your phone or if you have the calculator at school, you can just press the log button. Because remember, this is the same thing as saying log x over log b. You don't even have to have the tens. This is the same thing as saying log x divided by log of b. Why is that? Because you know that tens are there if they're not written. So let me show you an example. This is called changing base. Right, the base b is no longer the base. It's now just the number out front here. So we're going to practice going from this to this, and then I'll put them both into the calculator to show you that it works. So we do log base 2 of 30. I'm going to evaluate this by converting to base 10. So this would be log. Now remember, we have the top part is x. So we need to do log of 30 divided by log of 2. That's ugly. Jeez. Okay, so let's try this one first, then we'll see if it's the same answer. Log 30 divided by log 2. So log, whoops, I typed it in twice. Log 30, and then divided by log 2. So that would be 4.9-ish, 4.91. 4.91. So I'll type that into the calculator as well. So log, I'm going to do this side now, just to show you guys the same thing. Log base 2 of 30. So really, this is only useful if you do happen to have a calculator that does not have this button here. And what would that give us? Should be the same thing, 4.906, whatever. It also gives you the exact form here by changing it for you. I didn't realize that. So this is the same thing, the 4.91. So again, this is really only useful if you cannot type this into a calculator. But it's good to know as well. I'm going to try two more. So log base 4 of 5 would be log of just the number 5 divided by log 4. I'm just following this, trying to change it to this over here. So I'm going to, again, I'll type them both in so you can see. So we'll do log of 5. Maybe if I just do the slash. Ooh, I don't want to do that. Divided by log of, what was it, 4? 4. So that gives us 1.16. Now I'm going to check this just to make sure. Log base 4 of 5. Log base 4 of 5, which is also 1.16. All right, the last one, we can evaluate this as log of 4 divided by log of 8, and then we can go ahead and type it in. Log 4 divided by log 8. And I think I'm not going to check this one. We should know it works. So it's 0.6 repeating. 0.6 repeating. Or that's the same thing as saying 2 over 3. And you could type that in as well and check to see if it works. Okay, so you have a huddle. There's 3 problems here. I think I might go over some of the huddles just so you know how to do it and then finish up. So this one you're converting to base 10, which is what we just did. 2 is a little different. You're going to write this in exponential form if you remember how to do that. It's a little bit of a review here. So I'm going to show you how to do that. Write the following exponential form. So how we do this, we get rid of logs and we do the circle thing. So this would be 8 squared equals 64. And that is a true statement. B, you would do it again. It would be 6 to the x equals 98. You're not solving for x. It just says to write in exponential form. And the last one, oh, you don't have anything here. Should be equals to x. We'll do that. Then you can draw in the circle and do that yourself. The third one, we're actually going to evaluate these by just putting them into the calculator. And that's all you have to do, because these are all equal to x. So just practice typing them into the calculator. Log base 7 of 7. I think for the most part, we could do this in our head. So you can type in the calculator or just figure out this would be 7 to the x equals 7. So that would have to be the number 1 to work. This would be 3 to what power gives you 9. All right, just go around the circle. You don't need to log anymore. That would be a value of 2. And then the last one we would do, remember this would be the number here we use. 5 to the x equals 1 over 125. 1 over 125. So 5 to what power equals 1 over 125. Remember, to get this, you have to have a negative value. So it'd be negative 125. I think that's third power, because squared is 25 and third is 125. So this would be negative 3. So there you go. I went through most of the huddle as well with you, and you can just finish up part C of 2 and the rest of number 1. And that will conclude 9.5 that we're on now, or 9.7. That's 9.7.